because this is going to go back to some things from 3.2. So you can add it to like 3.2 notes, or you can just add it to the beginning of 3.3 notes, or however you want to do it. But just some things that we didn't have time to get to on Friday. Okay, if I were to give you an equation, like this. X squared plus 5x plus 8 equals 0. As we look at this, we want to decide, and let's just say I told you to solve this equation now. So if I ask you to solve this equation now, we could go back to all the methods that we talked about on Friday. And I know it's been a few days, but we could try to factor it, right? And if I said what multiplies to get 8 and adds to get 5, nothing works. So this does not factor, okay? I probably wouldn't do completing the square here. Completing the square is not going to really be a go-to. And you can look at all the different methods that we could possibly do, but even graphing it, if we graph this one, let's just look at what it looks like. Okay, so let's go through the quadratic formula here. Opposite of b, plus or minus. I like to go ahead and square the b value. I'm just plugging everything in. The other thing, just so I'm trying to tie everything together here. Whenever the number underneath the radical is negative, that immediately tells me my answer is imaginary. Remember, we called this number the discriminant. When this number is negative, that means we have two imaginary solutions. And so to finish this one out, we're going to bring that negative out. So this is going to become I radical 7 over 2. There's no way to simplify it. There's no way to do anything else. So this is our answer. And that's how we would leave it. You could break it up if you wanted to and do negative 5 halves plus or minus I radical 7. But the plus or minus here is why we have two solutions. And so whenever we have an imaginary answer, we're always going to have parity. And so once I have one, I always have another. And so the plus or minus allows us to get both of those. Okay. So I just wanted to show you one where the answer is imaginary, and that would be one where the quadratic formula is a definite. We got to do the quadratic formula. And so that's one reason why we do the quadratic formula, is because there's some problems it allows us to get our answer, whereas the graph does not. Okay. And so even though we love going to our graph if we can, it may not always be the method that we need to get to. All right, the other one I want to do with you, and this one is off your assignment. We're on page 203. I still don't really know why they throw this one into the mix on this, because it's not really a quadratic chemistry pattern. Okay, this one is a cubic polynomial. And that's why it's different than anything else that we did on Friday. And I told you there was one type of factoring that we did not do. So if you haven't done this one yet on your homework, you can just add this to your assignment. okay? And this is how we know it's different, right? It's not a quadratic because my highest exponent here is a 3. And I told you that for some reason they throw a couple of cubics in there. I think this was the only one on your assignment, but doesn't really fit with the rest, okay? So we call this factor by grouping, and it does give you that hint right there in the problem. But it's been a while since we've done this factoring method, and I want to show you what this looks like because there's going to be some down the road where we're going to do this. So I want to go ahead and at least talk about it. So when we see it, we can say, okay, yeah, we've seen it, we've done it. We call it factor by grouping because once this is in standard form, we're going to group it into 2 groups of 2. We're going to put parentheses around the first 2. We're going to put parentheses around the second 2. Okay, and what we do from here is we do GCF. So as I look at these first 2 pairs, or first group, we're going to say, what do they have in common? Well, I can take an x squared out. And that leaves me 3x plus 1. If I look at the second group, I can take out a negative 4. And that leaves me 3x plus 1. So if I truly can factor by grouping, if this really is going to work, the 2 parentheses that I get after I factor out the GCF should be the same. If those 2 are the same, that means we can definitely do this by factoring. And so here's the part that sometimes gets missed. We're going to combine what's on the outside. And then we're going to leave what's on the inside. So this is going to factor into x squared minus 4, 3x plus 1 equals 0. But what we're looking for here is where are my zeros? What are my solutions? Okay, and so we're not quite solved yet. We talked about this a little bit on Friday. What kind of factoring could I do here for x squared minus 4? It stops, yeah, because it's x squared minus 4. X squared and 4 are both perfect squares. So this could factor one more time into x plus 2, x minus 2, and 3x plus 1. Okay. And here's the other difference between this one and all the other ones that we did on Friday, and that's why, once again, I don't really love they just randomly threw this one in because it's all quadratics and then all of a sudden they throw a cubic in. Because it's cubic, that means we could have 3 zeros and 3 factors. Okay? If I set both of these, all 3 of these equal to 0, I'm going to get x equals 2. I'm going to get x equals negative 2. And then for this one here, I would subtract 1 and divide by 3. And that gives us negative 1/3. Okay, and we're going to talk about this a lot more as this chapter progresses. But because this has a degree of 3, okay, or an exponent of 3 in this case, then it could cross the x-axis 3 times. It's not guaranteed to, but that's the one thing that's different here versus a quadratic. A quadratic could cross it 2 times at the most, whereas a cubic could cross it 3 times. And if you put this into your calculator, these would be the 3 places that it crosses or touches the x-axis. Okay, and so I just wanted you to be aware of that and kind of know that that one's a little bit different, but we will be doing that more and more as we go throughout this chapter, especially. Okay, any questions from those or anything else from Friday before we move on to today's lesson? Okay, today we are doing some more work with quadratics. And we're graphing quadratics. There's a couple of forms that we're going to see today of an equation. Most of what we saw on Friday was what we call standard form, and that's the one that we use for like quadratic formula and for factoring and things like that. Well, we're going to see another one today, which is typically just used for graphing purposes, not really for anything else that we're going to do. Okay, so what we're going to start with here is y equals x squared. We call y equals x squared the parent function. That's where everything starts from. And we can think about all the way back to the last chapter when we talked about like the parent functions for all of those different graphs. We had like 6 or 7 different graphs that we said, okay, this is my original parent function where everything starts from, and then what kind of changes or transformations are going to take place from that. Okay, but today we're going to just focus solely on quadratics. We're not going to do all those other functions that we did in chapter 2. We're just going to focus on a quadratic, which makes it a parabola. Okay. The first format that we're going to talk about here is what we call vertex form. I'm going to show you the generic form for vertex form first, which is this. Okay. And you've seen this before. We haven't really talked about this much this year, but in Algebra 2, you talk about vertex form of a parabola. And one of the reasons why this is nice to graph is because it's in a form where I can determine what the vertex is like that. Okay, all I got to do is look at it. My vertex is the h and k value. Okay, now here's where we've got to be careful. And I'm going to show you an example here in just a second. Because this is minus, it's always going to be like the opposite. Okay, and this, you probably remember from last chapter, tells us we're going to move it left or right. Okay, whatever number is connected to the x on the inside of the parenthesis tells us how much we're going to move it left or right, but it's always going to be opposite. And then the k value tells us how much we're going to move it up or down. And that gives me my vertex. The vertex is the point where that parabola reaches its high point or its low point. And we're going to talk a lot about that today as well. Okay, the a value tells me if it's a stretch or a shrink, or in some cases, are we going to flip it over the x-axis? Okay. If it's negative, we would flip it. And so all of those changes are things that we've already talked about in chapter 2. So those should be pretty familiar to us, but we're just applying it to a parabola. Okay, so I'm going to give you an example here. F of x equals 2 times x minus 1 squared plus 3. Morning, Mr. Elligan. Okay, so this is what we call vertex form of a parabola. Okay, we should be able to look at this. Okay, so what does the minus 1 here tell me? What direction is it going to move? Right 1. Okay, what's the 3 tell me? Up 3. Okay, and so what that tells me is my vertex is going to be at 1, 3. Okay, what does the 2 tell me? Okay, my a value here is 2. So that tells me 2 things. this graph is going to open up because it's positive, right? It's going to be a parabola that opens up, and it's going to stretch vertically by a factor of 2. Okay, and once again, those are all changes. We've talked about them. We're going to keep seeing those changes, and we'll keep talking about those as we go throughout the semester, but today it's just with quadratics. Okay, and it's good to identify all of those things, because now what we're going to do is we're going to graph it, and that's really the focus of today. And can we use our calculator? No doubt about it. We want to use our calculator here, right? But we should also be able to identify things really quickly based off of what we can just look at the equation and tell. Okay, so on this one here, I'm going to go ahead and graph it. So I'm going to put this into the calculator, and if you guys want to do the same. What I like to normally do here is, what is the vertex? Okay, and when we graph this one, we typically like to get, and we could pull those right off of our graph. And could I do more? You bet, right? But in this case, those are going to be the big ones that we're going to talk about. Another thing that we're going to talk about today is the axis of symmetry. From here on out, I'm just going to write it as A of S, because I don't want to write out axis of symmetry every time we do it. So just know that A of S means axis of symmetry. I like to do abbreviations. The axis of symmetry is the line that goes right down the middle of this parabola. And it's always going to be a vertical line. Okay? And it goes through whatever the x value is for my vertex. So it goes through at 1. So we're just going to write that as x equals 1. So x equals 1 is what we call our axis of symmetry. It should split that graph right down the middle. And that's why we call it the axis of symmetry, because it makes the parabola symmetrical on either side. And one reason why that's kind of nice is because this point should just reflect over here. If I had a point all the way up here, I could just reflect it over that line. And I can reflect all the way up and down that parabola. Okay, another key thing today that we're going to be finding, and we did this last chapter as well, so this should not be something new to us. We just said that the vertex is at 1, 3. Well, for a parabola, it's either going to be a minimum or a maximum. You're not going to have both, okay? So this one is going to be a minimum because it's at the lowest point of the graph, okay? And my minimum here has a y value of 3. And we're going to write it just like we did in the last chapter. And that happens when x equals 1. So it's just a different way of writing the ordered pair. Okay, the max and min is always the y value, and it happens when x equals 1. Okay, so those are going to be some of the kind of key things that we're going to talk about based on the graph. And because we are focused on graphing, you know, as accurate as we can, we do want to come up with a few other points. The vertex is a key. You've got to have the vertex, and then we got to have at least one point on either side of that vertex for the parabola. Okay, so graphing out of vertex form should be pretty easy because we've already talked about a lot of those things and seen a lot of those things. So that one shouldn't be too bad. The one that's going to be a little bit more work is one like this. Okay, and I'm going to talk about all kinds of different things that we could find here. But we call this one standard form. This is the one that we saw a lot on Friday. The bad thing about standard form is that we can't just look at it and say, here's my vertex. That's why vertex form is much easier to graph, because I know what my vertex is, and then I can pretty much do everything based off of that. Standard form is a little bit more difficult to do. Now, I'm going to show you how you can do some things by hand. I know that you have your calculator, and using your calculator is not a bad thing, okay? But there's sometimes where like that vertex might be like a fraction, and looking at it on your calculator may not be real easy to do, okay? So I'm going to show you how you can find everything that you need by hand, but obviously your calculator is going to be a great tool to use as well. Should be very, very helpful here. Now, the first thing that I'm going to tell you here is A is -1. There's no number in front of the x squared, so we just assume that coefficient to be a 1 right there. And in this case, it's going to be a -1 because we have a minus sign in front of the x squared. And so what that tells me is that this graph is going to open down. And it's going to have a maximum instead of a minimum. Okay, in order to find, on this one, we're going to start with the axis of symmetry. Instead of finding the vertex first, we're going to find the axis of symmetry first, and we're going to use that to help us find the vertex. I can't just find out what it is by looking at the equation, but here is how you can do it really quickly by hand. There's a little formula that you can use. Okay, and I'm going to put a star by this because if you know this little formula, you should be able to find the axis of symmetry really easy. So in this case, we're going to do the opposite of 14 over 2 times -1. -14 over -2, which is 7. So my axis of symmetry is x equals 7. Hey, and as I've told you, we're going to graph a lot today. So what we're going to do is I'm going to go over 7. And I'm going to draw in that line before I ever graph my parabola. So this is the line that should be splitting that parabola right down the middle. Okay, next thing is we're going to find the vertex. On the last equation, we could just look at the equation and boom, there's my vertex. We can't do that here. But what I told you was the axis of symmetry and the vertex share the same x value, right? So we already know the x value of the vertex. The vertex has to land on that line somewhere. So it's going to have an x value of 7. How do you suppose we can find the y value of the vertex if I know the x value? For any equation, if I know the x value, how could I find the y value? Plug it in. Yep, that's all there is to it. Okay, so I'm going to go back to my original equation, and I want to evaluate that function at 7. So we're going to do -1 times 7 squared plus 14 times 7 minus 47. Okay, and you could put all of that in your calculator, and I know that you can find this vertex by just going to your calculator and doing your max and min, okay? But I'm showing you how all of these numbers and where they come from, right? There has to be a way to get there without just looking at your calculator every time. I don't have a problem with you finding the max and min from your calculator, so I don't want you to think you have to do it by hand every time. I'm just showing you how you could get there if you had to do it, okay? But I'm totally going to let you use your calculator to help you find this. So this would be 49, -49, plus 14 times 7, minus 47. So if we do all of that, what do we get? 2. So our vertex is going to be at 7, 2. Over 7 and up 2. It should land right on that line somewhere, okay? Now, we're going to do a few other things here. Let's go ahead and graph this and then I can just reflect those 2 points over my axis of symmetry. And that's one of the good things about the axis of symmetry. This point can easily just be reflected. If this one's 2 to the left, this one's 2 to the right. If this one is 1 to the left, this one is 1 to the right, okay? We're just reflecting it over that line, and now we're going to draw our graph, okay? And that's our parabola. And we can get those order pairs right from our calculator, okay? And I don't have an issue with that, okay? We just need to know what they mean and how we can use them to graph. Okay, so we've done all of this already. We've talked about axis of symmetry. We've talked about vertex. Now we're doing it on a different graph. A couple of other things that they're going to ask today, and they're not going to ask these on every single question, but on a couple of the questions, you're going to see a couple of other things being asked. First of all, we already talked about this. This one is going to have a maximum of 2 at x equals 7. Because this time it reaches a maximum point instead of a minimum point. So that's one thing that we're going to find a lot today. They're typically not going to ask us to find the domain today. Okay? Why do you think domain is not a question that they're asking today? Because we've seen domain all throughout the semester so far. Why are they not going to ask us about domain? What's the domain of a parabola? All real numbers, right? So every single parabola I graph, guess what the domain is going to be? All real numbers. So we would just be saying the same thing over and over again, okay? So that's why the domain really doesn't get asked today. But if it did ask us the domain, it would just be all real numbers, negative infinity to positive infinity, okay? One that they will ask us is the range, because the range will be different, okay? In this case, how low is this graph going to go? Negative infinity. How high is it going to go? Up to 2. Okay, 2 is where it reaches its maximum point. So we would say negative infinity all the way up to 2 inclusive. Okay, bracket, because 2 is included in that range. The last thing we're going to do for this problem is increasing and decreasing intervals. So this is another thing that goes back to some things that we've done before, but now we're going to do it with the parabola. The graph is increasing on the left, it's decreasing on the right. When I do increasing and decreasing intervals, we're only going to deal with the x values. So this graph is going to keep going to the left forever, right? So it's going from negative infinity all the way until it gets to 7. So this graph is going to increase from negative infinity all the way to 7. When we do increasing and decreasing, we don't have to worry about brackets versus parentheses. We just use parentheses. Because at 7, it's neither increasing or decreasing. And then at 7, it begins to drop. And it's going to keep dropping forever. So it's going to decrease from 7 to infinity. If my graph opened up, it would be just the opposite. It's going to decrease on the left and it's going to increase on the right. Okay, and so it would be just the other way around. Okay, so those are some things that we've talked about before that we're going to tie into what we're doing today, and some questions we'll ask to find those things. All right, the last thing that I'm going to talk about here is how to go from standard form to vertex form. These are the two forms that we've already talked about today. Standard form is used a lot to help us solve and do things like that. Vertex form is used more for graphing. So if I wanted to graph this, I could do it either one, right? But we're going to talk about how the two kind of relate to one another. So I'm going to give you an equation here. X squared plus 4x plus 5 equals 0. I'm going to go ahead and set it equal to 0. And on Friday, I told you that when we did completing the square, there's some other places where we use completing the square. and this is one of them. Okay, but we're not going to use it to solve, we're going to use it to rewrite this in vertex form. Okay, so first step when we did completing the square on Friday, we said we got to move the constant. So this becomes x squared plus 4x, and that's where we add the blinks in. Okay, second step is we have to complete the trinomial. And when we completed the trinomial, when we did this on Friday, we said we're always going to take the b value divided by 2, and we're going to square it. So in this case, it would be 4 divided by 2, and we're going to square it. Well, 4 divided by 2 is 2. 2 squared would be 4. But whatever I add to one side, always have to add to the other. So we got to add 4 to both sides. Okay, and then as we look at this, we're going to factor this basically. And so if I said what multiplies to get 4 and adds to get 4, we would say 2 and 2, right? That's the same number that I get when I divide by 2 here. Okay, and so when I rewrite this, we could say x plus 2 times x plus 2, but there's no reason to write it separately, so we're just going to say x plus 2 squared. And over here on the left, or the right-hand side, negative 5 plus 4 is negative 1. Okay. And then to finish this out, on Friday we solved. We tried to get x by itself. Here, we're just going to get it back into vertex form. So I'm going to add 1 to both sides. And now we're in vertex form. And if I asked you what the vertex of this graph is going to be, what would we say? What's this tell us? What direction are we going? Left 2. What's this one here? Tell us. Up 1. Okay, so left 2 and up 1 means my vertex would be at negative 2, 1. Okay, I just want to show you how these two work together. And another place where we might see completing the score being used, we probably won't do that a lot where we change from one form into the other, because for me, if you're just going to graph it, we'll just graph it out of either of the forms, and we can put it into our calculator and graph it. But that is kind of where those two go together. All right, assignment for today. Through 40 by 5s.